Assalamu alaikum friends. Today we are going to learn about Dijkstra algorithm. Don't call it Dijkstra because it's a French word and the name of the algorithm is Dijkstra algorithm. Okay, so this is a very important algorithm. And if you want to learn it with me, don't forget to like the video and subscribe to the channel so that I get more and more subscribers and I can explain the concepts better to all of you. So in this Dijkstra algorithm, we are actually talking about a single source shortest path algorithm. We need to reach all the points starting from a single point. Basically, the approach that this algorithm follows is the greedy approach. But with the help of this greedy approach, this algorithm tries to get optimum solutions. What I mean to say by this, I'm going to explain you with the help of this very small example. For example, you are standing on a point 1 and you want to reach point 2. Then you have a cost, or you can say that the distance is 20. Similarly, when you are standing on point 2 and you want to reach 3, your distance is 10. And if you do not want to go via 2 to 3, you want to go directly to 3, then your cost is 40. But we do not know that even if these given costs are 40, we want to start from the single source and we want to get the shortest path to reach, for example, 3. We do not know right now that whether this is the shortest path or this is the shortest path. So how we approach in with the help of this Dijkstra algorithm was simply take the initial cost sets infinity. We say that if this node is called u and if this node is called v, so the initial cost that I am going to get for reaching from u to v is infinity. In the first step it is infinity, but in the second step I am going to assume that I am going to do some relaxation. Now what do I mean by relaxation? By relaxation I mean that if the cost of reaching u vertex when standing at reaching v vertex when standing at u, it is called du, and the cost of reaching v from u. So if you are standing on u and if you want to know about the cost for reaching u, of course it will be 0 because you're already standing on u. So this cost is going to be 0, this cost is going to be 20, which is given over there. And if it is smaller than the dv, and dv I just told you that dv is initially considered as infinity, initial cost is considered as infinity, this is the value infinity. So if this summation is smaller than infinity, of course it is smaller than infinity, then it means we can say that this dv is equal to du plus cu p, which is equal to 20. So you have added this 20 into 0 and you have got that yes, the cost that I'm going to get from walk starting from this point u reaching this point v, this cost is equal to 20, right? In the similar manner, we say that if you want to reach from point 1 to 3 directly, like we want to follow this path, not this path, we want to follow this direct path, then in this case again we are going to use the same relaxation equation. Initially we considered that this cost is going to be infinity. All right, this is going to be our initial consideration or initial cost in each and every calculation. But later on when we do the relaxation, we say that du plus cuv is less than, if it is less than dv. What is du? The cost of reaching u when you are already on u, of course it is 0. And what is cuv? Cuv, as you can see in this question, it is 40. So if it is smaller than infinity, of course it is smaller than infinity, then simply your dv is equals to du plus cuv. All right, so your dv will become 40. You add this 0 and 40 together and that becomes the value of this dv, and this is only true if these two summations are less than infinity. So now you have got two costs. One cost is 20, which was the cost for reaching from here to here, and you have got the second cost as 40, which is the cost for reaching from this single point to here. In this complete question, do not forget that what we are actually doing, we are trying to get single source shortest path. We are trying that whether this path is shortest to reach this vertex 3, whether this path is shortest to reach this vertex 3. So we are trying to find out that single path, that single source shortest path with the help of Dijkstra algorithm. Okay, so we got 20, we got 40. Now similarly for reaching from 2 to 3, oh yeah, we just reached over there, we haven't reached here yet. So again, for reaching from here to here, we will assume that if 20 plus 10, see the cost of reaching u, when you are on u, it's 20, it's not 0, because you have to always start from the single source. This is the catch in this algorithm. If you are now calculating the relaxation from here to here, still you will add this cost, because the algorithm says that you are always starting all calculations from a single source, which you assumed was this one. So now we do not take this du as 0, we take du as 20, and the cost for moving from u to v is 10. You can see in the question it is 10, so you added 10 here. And if it is smaller than, so will you say that if it's smaller than infinity? No, you cannot say it as infinity, because why? Just tell me, do you understand why it is not infinity? Yes, because we have already calculated that this is 40. We have already calculated on the first step that the cost of reaching this point, this 3 point, is 40. So we have to compare it with 40, not with infinity. Infinity was the initial cost, the initial assumptions of dv, but since we have already calculated that dv is either 40 in the case of this path and dv is 20 in the case of this path, and we know that now we are talking about reaching this node, we are already standing on this node, so we have to take dv as 40. So now if you compare 20 plus 30 plus 10, it becomes 30. And is it smaller than 40? Yes, it is smaller than 40. Okay, since this is true, so we will assume, we will proceed that dv is equal to summation of du and cu, 20 plus 10, which makes 30. So now in the case of this path, this distance is 30. This cost is no more infinity, this cost is 30. So in this way you have calculated all the costs and you have relaxed these points. These are the new costs in place of infinity. Now these are the new costs. So with this I conclude the overall understanding of the Dijkstra algorithm, that this algorithm always starts all its calculations from a single source. It wants to find out the shortest path to reach all the points in your graph. You have to start from single source, and one by one you try to reach all the sources. Initially you initiate the initial costs as infinity, and then one by one you relax those costs with the help of, you add the cost of the first node where you are standing, which is your source node, and you add the traveling cost into it, which is normally given onto the arrow. And if this summation is less than infinity, then you make this value, this dv, equal to the sum of these two values, and you equate it equal to that. So this is how we use Dijkstra algorithm. In the next video we are going to solve a larger example, which can be actually your exam question. If you like it, then do proceed to my next video as well. Thank you. Allah Hafiz.